Okay. The next topic is sampling with oversampling. So, what do we mean by oversampling? Okay. Oversampling is important if the event that you're trying to predict is a rare event. So, for instance, if you're trying to analyze fraudulent transactions, okay. So you have millions of transactions flowing in, and maybe a tiny fraction of all of those transactions are fraudulent. Okay. Very small number. Okay. But it is important, even though it is a small number, it could be large amounts, or they may add up to large amounts. So we want to detect those rare occurrences. So if you look at a regular data set that you have collected, okay, so maybe only 1% or less than 1% are fraudulent transactions, and because of that, the methodology that you use to try to predict the fraudulent transaction is going to have a hard time finding those very rare observations. So in order to understand the characteristics of the observations of interest to us, we want to make sure that sufficient number of those observations are included in your sample. So you'll have enough of the event of interest you have, okay, the event of interest, you have enough of them in the sample. So that is called oversampling. You try to sample more than the normal. So if you have 100 observations, if you're randomly selecting from those 100 observations, say 10 of them, each observation will have a 1% chance of getting selected, right? Because you're selecting at random. But suppose if that in that 100 observations, 10 of them are the events that you're interested in. So you say, I'm going to select not completely at random, I'm going to select of those 10, 5 of them. And from the rest of it, I'm going to select at random 5 of them. So now in the sample that you have, 10 observations, 50% are the event of interest. So you'll have sufficient number of events for us to do the analysis. So that is called oversampling. So you're trying to assign a higher probability of getting selected for those rare events. So in your sample, you'll have sufficient number. So that is the basis of or reason why you want to do oversampling. And suppose in this example, you want to include, okay, you want to oversample houses that have more than 10 rooms. Okay. All right. So you'll use the probability parameter, okay, of the sample code to achieve that. Okay. So oversampling with 10 rooms, we can do that using the probability parameter. Okay. So now once again, let's do set seed 1. Okay. And then we will do sample, still row names, housing the F. Okay. All right. So now let's say that we want to select 20 observations. Okay. But we want to oversample those observations that have 10 or more rooms. So you can do that by assigning a probability. So you do probability equal to, you assign different probability for, okay, a smaller probability for observations where the number of rooms is less than 10. Okay, let's assume that we want to give 90% probability for over 10 rooms, right? And only 10% probability for the rest of them. So we can use the if-else code, and if-else acts exactly like how if function is used in Excel. In Excel, so you have if, you have a condition, and then comma, the value if the condition is true, and then next item is value if the condition is false. Right? That the same thing. If else is the command. Okay, so let's put that in a line like that. So inside if else, so we will put the condition. First item is condition. Okay, so you want rooms, okay, greater than 10. So if rooms is greater than 10, then you say probability is 0.9, otherwise it is 0.1. Okay. So the lines of observations with more than 10 as rooms will be sampled at a 90% probability rate, and the rest of them at 10% probability rate. Okay. So then we can subset those rows. All right. Okay, so now we have the 20. So let's look at the number of rooms so this is you need to look at number of rooms, how many observations are there with the number of rooms Okay, so you see greater than 10 rooms is what? Only about 120 observations. Out of the 5,800 observations, a very small fraction has more than 10 rooms. And from that, you're selecting at 90% rate, so you get one observation that qualifies as more than 10. The rest of them, with 5,000, close to 5,500 observations, are less than 10, less than or equal to 10, and 10% of that is getting selected. So oversampling is done through probability.